Hey guys, so for all experiments that needs a spectrometer, the first thing you should do is take the normal incidence. What this does is makes sure that you get the maximum intensity light for all your readings. So I'm going to teach you how to do that today. So this is a spectrometer. This part is a telescope. The telescope can be moved. This is the collimator. The collimator is fixed to the body and cannot be moved. This is a grating table. This is where you insert your grating. This is the focuser for the telescope. This is the focuser for the collimator. And at the tip of the collimator, you have a knob here which adjusts the width of the slit through which your light can pass. So first things first, we have to focus the telescope on a distant object. All we do is move the telescope to the side, look through the lens, and use the focuser on the side to get the best focus you can for any object at a distance. Once this is done, you move the focuser back to the original position, the telescope, and you do not touch the focuser of the telescope again. For the next part, you need a dark room. What we're going to do is close the curtains and bring in a source of light, which could be a hydrogen lamp, sodium vapor lamp, anything. Here I'm just using a regular table lamp. We're going to open the slit a little wider than necessary to allow maximum light to flow in initially, right? See where you find the maximum light on the telescope. And once you get that, we rotate this knob again to close the slit. Once this is done, you will notice that your light is still a little unfocused. So you will use the focuser on the collimator to focus the light. This is your initial setup, part of your initial setup. So now we have one narrow glowing strip of light. Next, use a spirit level to make sure that your grating table is completely flat. So we'll keep it this way. Then we'll keep it parallel to the y-axis and then parallel to the z-axis to make sure that it's perfectly parallel to the table on all sides. Next, we have to add a grating plate over here. Then we move the telescope 90 degrees either way. So I'll move my telescope 90 degrees this side. The reading was exactly 90. So I'll adjust it such a way here that this scale reads 180 degrees. The next part is finding the reflected rays. So for that, from this position, we look through the telescope and we turn the grating plate in such a way that we see the reflected rays. You will usually see 3 lines. After you see the reflected rays, we'll move our telescope back to the original position, which for me was 90 degrees. Then we move the vernier table 45 degrees in the other direction of which we move the grating plate. So I will move it anti-clockwise by 45 degrees, which for me will be 135 degrees. When you look through the telescope again, you should see a single brightly illuminated slit. This is your normal incidence. The reading that you take over here right now will be your direct reading for all the spectrometer experiments. Now, to look at the spectrums, you just have to move your telescope to the left or to the right and then follow the procedure for your respective experiments. So here's how we take the main scale reading. In the main scale, 20 main scale divisions makes up 10 degrees. So one main scale division makes up 0.5 degrees or 30 minutes. So I'll just take this reading for example. Here we see that the 0 in the vernier scale is just a little bit beyond the line showing 200. So since the 0 line in the vernier is just a little bit beyond 200 on the main scale reading, our main scale reading will be 200. Now we need to see what our vernier scale reading is. So from what I can see, the 5th line over here coincides with the 5th line on the main scale reading. So my vernier scale reading will be 5 minutes. Therefore, the total reading will be 200 on the main scale plus 5 minutes on the vernier scale, which is 200 degrees, 5 minutes.